Here we are for section 10-2, more area. All of chapter 10 is that area. So yesterday you guys did the area of parallelograms and triangles. Today we're going to do trapezoids. So I've seen rhombuses or rhombi, you can say it either way you want, and kites. Okay, so we'll start off with trapezoids. Trapezoid MNPQ is split into two triangles by diagonal QN. MN and PQ are parallel bases. So remember that trapezoids always have one set of parallel sides. We call those the bases. And then there are two legs that are not parallel. Okay? The altitude or the height is going to be the same for both triangles. So like the height of this triangle is from here to here. That's the height. Okay? And then the height of this triangle, we're going to draw that outside the triangle. So we'll basically go from this part of the triangle, this vertex, straight down to the opposite side. So the height is outside the triangle. And then we know that these two heights are the same because they are the distance between the bases. And when lines are parallel, they never get closer together or further apart. So this height here is going to be the same as this height here. Give me 1 second. You need to turn that down. Okay, sorry about that. So if we want to find the area of a trapezoid, we could just break it into two triangles and find the area of each triangle. So for the first triangle, this one, it would be 1/2 the base, B1, times the height. And we're going to call that H, H for height. And we're going to call this height the same thing. Since they're the same height, we don't have to call this H1 and this H2. We can just call them both H because it's the same. Okay? So then the area of this triangle is going to be 1/2 the base, called B2, times the height, called H again. So here's the area of one triangle, here's the area of the other triangle. If we add them together, we get the area of this trapezoid. Okay? Now, what we're trying to do is come up with a formula so that you don't always have to take a trapezoid and break it into two triangles. We're trying to derive a formula that'll work for any trapezoid. So what I'm noticing is that these two terms have a greatest common factor. The greatest common factor is 1/2 H. So I'm going to factor out 1/2 H. When I do that, I'm left with B1 plus B2. So both of these terms had 1/2 H, so I factored that out. I was left with B1 plus B2. This is our formula for any trapezoid. We don't need to do anything else there. Okay? So it says, therefore, if a trapezoid has an area that we're calling A, bases called B1 and B2, and a height called H, then area is going to be 1/2 the height times base 1 plus base 2. That is your official formula for a trapezoid. So let's try to use that. On example 1, we have a trapezoid. I know it's a trapezoid because it has one set of parallel bases, and then it's got two legs that are not parallel. So I'm going to use my formula. Okay, the height is the 9.2 centimeters. And then the bases are 19.1 centimeters plus 22.6 centimeters. Okay, and then we will simplify that from there. So 1/2 of 9.2 is 4.6. And then inside the parentheses, 19.1 plus 22.6 is 41.7. Okay, and then we multiply that together. We get 191.82. Centimeters times centimeters would be centimeters squared. So you probably noticed that yesterday. Area is always some unit squared, okay, because area is two-dimensional. What does centimeters squared look like? Another way of saying centimeters squared is saying square centimeters. So a square that is a centimeter by a centimeter, that is a square centimeter, or centimeters squared. So a lot of times with like houses, they'll say, oh, this house is 1,000 square feet. That means on the floor of the house, you could fit 1,000 squares that were 1 foot by 1 foot. Okay? All right, example 2. What is the area of trapezoid PQRS? So I noticed on this one that I've got my two bases, but my height is not labeled. But I do notice there's a 60-degree angle right here. So what I'm going to do is I'm going to drop down another height right here. Okay? And let me zoom in on that a little bit. If this top is 5, this part is also 5. And then we know that the total is supposed to be 7. So if this part's 5, this part has to be 2 for a total of 7. Okay? And in a 30, 60, 90 triangle, across from the 30 is our n, and this is our n square root 3. Okay? So then we can do our area formula again. Okay, our height is 2 square root 3, and our bases are 5 meters and 7 meters. Okay, half of 2 square root 3 is just square root 3. Inside the parentheses, I have 12 meters. And then when I multiply that together, I get 12 square root 3 meters squared. This would be our exact answer. And then that is approximately 20.8 meters squared. Hey, Emily, can you go find me that calculator, please?
Oh.
Okay, so let's talk about exact versus approximate area. That's one thing that we said we were going to concentrate on this trimester. Just knowing the difference between the two. Remember, exact means that I have not rounded. This is approximate because this is not exactly what the answer is. I've rounded it. It was really 20.784609, so on and so on. So this is our rounded answer. This is approximately what the answer is. Okay? So you just need to pay attention on all of your problems as to what type of answer they are asking you for. We need to be able to do both. Because different situations call for different types of answers. Okay? All right, so let's flip over to the next page. So moving on to rhombuses and kites, we're going to list some things that we remember about a rhombus. Okay? So some things that I want you to remember is that diagonals bisect each other. Okay, something else that I want you to remember is that the diagonals are perpendicular. And I think that's it for now. If I think of something else we should add up there, then we'll go back and add it. Okay, so I'm going to show you how we get the formula for the area of a rhombus. Once you have the formula, you can just use it. But where does it come from? So basically, this rhombus can be split into two triangles again. So triangle ADB, that's this triangle here. Okay, and then triangle CBD, which is this triangle here. If I want to find the area of a triangle, I do 1/2 base times height. So for this triangle, the base is DB. I can choose any side to be my base. I'm choosing DB because remember the diagonals are perpendicular, so all of these are right angles. So if I choose this as my base, it has a height to go with it. Base and height always have to make a right angle. So AX would be my height. And then for the other triangle, I'm going to do 1/2 base times height again. So for this triangle, again, I get to choose my base. I'm going to choose DB as my base. And then it has a height to go with it, CX. Okay, and then I'm going to make a substitution. We know that diagonals bisect each other, so AX and CX are congruent. That also means they're equal. Okay, so I could remove CX and replace it with AX because they're the same thing. Okay, so I've done that. This is by substitution. All right, and then again, I notice that I have, well, let's see, how do I want to do this? Okay, so if I have 1/2 dBAX plus 1/2 dBAX, if I add those together, I just get a whole, one whole dBAX. So a half plus a half equals a whole. So I have dB times AX. Okay, or 1 dBAX. All right, so I'm going to keep the dB, and then I'm changing AX to 1/2 AC. Okay, so here's AC. And since both of these are equal, AX is the same thing as half of AC. So instead of writing AX, I'm going to write half of AC. Okay, and then I'm going to say, okay, what is dB, what is AC? I have the 1/2, I'm going to put that out front. And then I notice that dB is a diagonal, and AC is also a diagonal. So really what I'm doing is I'm taking 1/2, and I'm multiplying it by the two diagonals. So diagonal 1 times diagonal 2. So that is the formula for the area of a rhombus, and we can always use that from here on out. So if you have a rhombus, and A stands for the area of the shape, D1 stands for a diagonal, D2 stands for the other diagonal, then our area is always equal to 1/2 times D1 times D2. Okay? Now, I could basically go through that same type of exercise with a kite. A kite is not the same as a rhombus. Okay, one's a parallelogram and one is not. But a kite also has perpendicular diagonals. And remember, you can fold a kite. So if I took this kite right here and I folded it down, this part here would be equal to this part here. So this diagonal is bisected. Okay, so basically the exact same thing that I just did up here. The diagonals were perpendicular, and this diagonal was bisected. Then I can split it into two triangles, and I could basically follow this same exercise with this shape here. So even though this is a completely different shape than a rhombus, we can use the same formula to find area. I can take 1/2 diagonal 1 times diagonal 2. To find area. Okay, so let's give that a try for both shapes. So for example 3, a rhombus with AX as 10 centimeters. So this right here is 10. Okay, and then BX is 25. And again, we need to remember that the diagonals bisect each other. So if I have 10 here, I also have 10 here. And if I have 25 here, I also have 25 here. Okay, so then when I do my formula, okay, diagonal 1 is 50 centimeters, and diagonal 2 is 20 centimeters. Now you have to be careful here. A lot of people think that we need to like distribute the 1/2, but that is not how multiplication works. okay? We would only distribute if there was like a plus sign in between the 50 and the 20. But this is just 3 different things being multiplied together. So you multiply 2 at a time. So you've got a couple of options. You could say, all right, half of 20 is 10, and 10 times 50 is 500. Okay? Another way of doing it would be, okay, I'm going to do 50 times 20. I get 1,000. And then I'm going to take half of that. I get 500. Or the final option is to take half of 50, which is 25. 25 times 20 is 500. So no matter how you do it, you're going to get 500 centimeters squared. Okay, just make sure you do not distribute the 1/2. This is not 25 times 10. That is not how you do this, okay? All right, and then part B, it says that DH is 3. I'm going to zoom in here because I'm going to have to write really little. So DH is 3. Okay, and EH is 2. GH is 5. And remember, if we fold this kite down, if I have 3 here, I will also have 3 here. Okay, so then we'll do area equals 1/2 D1, D2. Okay, so one of our diagonals is 7 meters. And the other diagonal is 3 plus 3, or 6 meters. And when you multiply those 3 numbers together, you're going to end up with 21 meters squared. Okay, and then the last problem, trapezoid PQRS has an area of 250 square inches. Find the height of PQRS. So this is a trapezoid, so I'm going to write down my trapezoid formula. And I'm going to plug in everything I do know to this trapezoid formula. So it actually told me that the area is 250 square inches, or 250 inches squared. So I'm not trying to find area this time. They gave me area. What I'm trying to do is find the height. So I'm going to leave height as h because I don't know what it is. And then my bases are 20 inches and 30 inches. Okay, and then I'll simplify. Okay, and at this point you have several options. You could multiply both sides by 2 to get rid of the 1/2. Another option is you could divide both sides by 50 to get rid of the 50. And the third option is the one I'm going to do, is I'm going to just combine half of 50. So on the left side, I still have 250 inches squared. And on the right side, I'm just simplifying the right side. So half of 50, that's 25 inches. And then times height. And then I will divide both sides by 25 inches. Okay, on the left side, I get 10 inches squared divided by inches gives you inches. And then on the right side, everything cancels except for the h. So we have h left over. So my height is 10 inches. Okay, so before I give you your assignment, I do want to do one other thing because there's some more challenging problems in the book. Okay, so for example, you might see something like this. So maybe a rhombus. And let's say that they give you 5 here and 4 here, and they tell you to find the area of this rhombus. Well, I think, okay, area is 1/2 D1, D2. Okay, diagonal 1 would be 4 here and 4 here, so 8. But the trouble is I don't know anything about the other diagonal, okay? So what am I going to do? I have to remember that the diagonals of a rhombus are perpendicular. Okay? So then I'll look right here at this right triangle and say, if I know two sides of a right triangle, I know how to find the third side. I just do the Pythagorean theorem. So I would go a squared plus 4 squared equals 5 squared. And when you solve that, you would end up with a equals 3. Okay, I'll let you do the work on your own there. So this would be 3, and this would be 3. So our other diagonal would be 6. And you'd end up with 24 units squared. Alrighty. Thanks, guys.